And people, if you're going to teach this to other people, this is by far the way that I would do this, okay? All right. We're going to talk about a special triangle called the 45, 45, 90 triangle, okay? And I'll try to go kind of fast through this, okay? The way I want you to visualize this, if you're ever wanting to teach this to someone, this is the way I would visualize this. If you take a square and you cut it in half like this, okay, you end up with a 45, 45, 90 triangle, okay? All right. So let's see. Zeph, you're there, Zeph? You were kind of good at this already, right? So I think you
I'm
gave
here.
one of the answers. Okay, Zeph. All right. What's the relationship between this side and this side of the triangle? Because we're looking at the triangle now, right? What's the relationship between this side and this side?
They're both the same
Why would they have to be the same? What's the logic of that?
because each of their opposite angles is the same.
Simpler than that. If we're thinking about the square, come on. Remember, this is just a square that's been cut in half, right? When you cut a square in half, you get a 45, 45, 90. So there's a simpler answer to that.
All sides of the square are the same.
Right. Okay. So that's the first thing. We should all know that logically, right? If it's a 45, 45, 90 triangle, so if they ever give you one and you sketch it, what I would do if I was teaching it is I would turn it into a square by doing that. Because now you know these are equal. Okay. So that's the first thing. If this is 2, then this is 2. Yeah?
Yeah.
All right. So let's keep going. What if this was, so if this was 3, this was 3 then, right? Agreed?
Yeah.
45, 45, 90? Okay. So how do we find out? You probably already know this, but what is that length going to be?
Side times the square root of 2.
Okay, so this will be, we're going to explain it right now, okay? This will be 2 root 2. So let me explain it to you. If these two sides are 2, remember what we have here. We just have a right triangle, right? So we know that 2 squared plus 2 squared must equal, we'll call it the hypotenuse squared. Everybody okay with that? A squared plus B squared equals C squared, right? So 2 squared plus 2 squared equals H squared. Well, that's 4. That's 4 plus 4 equals H squared. So that's 8 equals H squared. All right, go ahead, Zeph. How do I simplify? How do I solve for H? Go
Square
ahead, do
root
it.
both sides.
Square root both sides. We get H is equal to the square root of 8. Okay, somebody, who was in my class week 1 when we learned how to simplify a radical? Who was there? Anya, you were there, right, Anya?
Yeah, for number sense too.
Yeah, good. So how do we simplify a radical?
You can take the square out, so it's 2 times square root of 2.
I'm going to call it 2, 2, 2. And this is a square, right? 2 squared
Yeah.
is, so that I can bring that out, right? So that's 2. Ah, so this is 2 root 2. Got it? Now, what if it's 3? Anya, back to you. Let's say if it's 3. So look at this one. This was 2, 2, so it's 2 root 2. The question is this 3 root 3 or is it 3 root 2, right? That's the question. We can see a pattern, right? 2, 2, 2 root 2. 3, 3, is it 3 root 3 or is it 3 root 2? That's the question, right? So let's do it. So we get what? 3 squared plus
3 squared
equals
and equals 9 plus
8.
9.
So 18, right?
Yeah.
So we square root this, and we break that down. What do we get?
Uh,
2 times,
3 times, 2 times 2 times,
no, be careful.
I'm getting confused. 2 times
Yeah,
3 times 3.
right, because 2 times 9 and 9 is 3 times 3. You can think of it as a square if you want, right? So you have a pair of 3's, so they come out and they make a 3, right?
Yeah.
So we get 3 root 2. Now, do you see the pattern here, right? I don't know if you already knew these. When these were 2, this was 2 root 2. When these were 3, this was 3 root 2. You get the pattern? Back to you, Anya.
Oh, yeah.
Okay, so what if these were 5?
Then it would be 5 times square root of 2.
5 root 2. There you go. Okay, so there's the pattern. I want you to, if you don't already know this, even if you do know it, write it down, okay? Okay, so 45, 45, 90. If I have a 45, 45, 90 triangle, remember that it's really just half of a square, okay? These will be the same. We'll call these both X, right? Because this will be a 45, 45, 90 triangle. And this will always be X root 2. So let's do a couple problems. We're going to go faster at this. Ready? All right. So let's say this is 10. This is A. This is B. Who's next? Adam. I know you can do this already. Go for it, Adam. If that's 10, what's the other? What is A and what is B?
A is 10 and B is 10 root 2.
10 root 2. Simple. He's done this for a while. All right. So let me change this. What if this, guys, was 7 root 2? What is A? What is B? Arjun. Sorry, Albert. Albert, if the hypotenuse is 7 root 2,
7.
A and B would both be 7. Good. Okay. Okay, let's stop there for a minute because I'm about to make this harder. Okay. There's another question they ask sometimes. All right. Well, actually, let me just start doing it. All right. So what if this was 10? Okay. Okay, first step.
It would be 5 square root of 2.
It would not be, yeah, it is going to be. What? I'm curious, what did you do?
So 10 divided by square root of 2, and you want to simplify the radical denominator, so you multiply by square root of 2 for both sides, and you get 10 square root of 2 divided by 2, which equals 5 square root of 2.
Okay. All right. You're totally understanding it. Okay. I'm going to slow this down for people who've not seen this before. Okay. If that's 10, then that means these two, and we know it's a 45, 45, 90, right? These are equal. So you know that these are both x, and this must be whatever x is times root 2. Yeah? For people who've done this before, I'm probably slowing you down right now, but I want to make sure everybody understands it, right? If that is, if those are both x, then that must be whatever x is times root 2. So you're going to divide both sides by root 2. Because 10 is equal to x root 2. So x must be equal to 10 divided by root 2. Okay, so somebody who's done this before, what's the problem with that answer? I can't write that as an answer.
You can never have a denominator that's a radical. I mean, that's
Okay, so
improper.
you actually can, but we just have a rule. There's nothing wrong with it anymore because we use calculators now. But in the old days, before calculators were invented, you could not have radicals in your denominator because they made the math way too hard. Okay? I think it's because you would have to do 10 divided by an estimation of root 2, and the math would just get ugly. Dividing with repeating the long decimal is not fun. Yeah? So we didn't like in the old days to have radical denominators. Okay, so I need to talk to somebody who's never rationalized a denominator before. Who's in here has not rationalized a denominator? Because I want to teach it to you.
Me?
All right, who's me? All right, Arjun, that's good. All right, perfect. You're next on the list. You're close to the next on the list. All right, Arjun, do you understand that when we do this, we can't have root 2 in our denominator? Okay?
Yeah.
Okay, so if I had a fraction, Arjun, let's just make up a regular fraction, like 2/3. What could I multiply the fraction by to make it equal to it?
To make it equal to 2/3,
Yeah, to 2/3. What could I do?
you can multiply by 1.
Okay, fine. 1/1. That doesn't help me. It's just 2/3, right?
Yeah.
Okay. Couldn't I multiply the numerator and the denominator by 2? Would that work? If I multiply the numerator and the denominator by 2, what do I get? 4, 6. Is
Yeah.
4, 6 equal to 2/3?
Yeah.
Why does that work?
Because you're multiplying by the same in the numerator and the denominator. So
Yeah, but why would multiplying by the it's the same numerator and denominator work? It just seems kind of random to me. It's not random, but there's something mathematically going on. You're multiplying the numerator and the denominator by 2. So look what you're doing, bud. You're multiplying by 2/2. What is 2/2 really?
1.
1. I'm just multiplying by 1 in a weird way. Does that make sense?
Yeah.
So I could multiply by 3/3. And this is why this works when we learn this in whatever grade, right? If we multiply the numerator by 3 and the denominator by 3, we're getting 6/9. And the reason that works, we don't really talk to the kids about it when we teach it to them. But the reason that works is we're just multiplying by 1. That makes sense logically?
Mm-hmm.
Okay. So we can multiply it by anything that's 1. We could multiply it by 3/3, 4/4, 5/5. We could multiply it by anything we wanted. Okay? You follow me?
Yeah.
Okay, so we have this. We have 10 over root 2, right?
Mm-hmm.
We could multiply this by 2 over 2 and not change it, right?
Yeah.
And what does that do? That gives me 20 over what?
2 root 2.
Well, that didn't help, did it?
No, not really.
No, not at all. We still have a radical. Now we have even more numbers there. Okay, so it's not 2. What else could I multiply by? Try something.
3.
All right, let's do 3. So then we get 30 over 3 root 2. It doesn't help, does it?
No.
Okay, so the first time when you first learned this, so people who already know this, somebody taught it to them, okay? It's not intuitive. What if I was just wild and crazy and I multiplied by root 2 over root 2? Now, what is root 2 divided by root 2 really?
1, I guess.
1. Yeah, it is. Root 2 divided, something divided by itself is always 1, yeah? Okay, so what does that do for me?
So that means it's 10 root 2 over 1.
Over root 2 times root 2, which is, there's two ways you can think of this. That's root 2 squared, or that's root 4. You get the same answer either way. What's the
Oh,
square root of 4?
2.
2. Look what that did for me. Yeah? That ended up with 10 root 2 over 2. Now the denominator doesn't have a radical. Yeah?
Mm-hmm.
And this simplifies, right? 10 divided by 2 is 5. So what
It's
somebody
5 root
said,
2.
5 root 2. Okay, now let's do it again. So remember that one. So what if it was 7 over root 2? Okay.
Would multiply by root 2 over root 2, and you
All right,
would
let's do
get
the math. 7 root 2 over,
2.
yeah, because we get root 2 times root 2, which is root 4. Root 4 is 2. So we'd get 7 root 2 over 2.
Yeah.
Yeah? This one, we didn't see it at the time, but we got 10 root 2 over 2, and then we simplified it. Look what happens. So let's see if you can see the pattern. When it's 10 over root 2, it became 10 root 2 over 2. When it was 7 over root 2, it became 7 root 2 over 2. So what if it, let's see if we can figure it out. What if it was 9 over root 2? What do you think would happen?
It would be 9 root 2 over 2.
And that's what happens. So this gets moved to the top, and then you square this, and that's what's on the bottom. Do you see the pattern?
Yeah, I do.
Which is, who did that earlier? Was it you, Albert? Or what? Who was it earlier that said something? Was it you? I think it was you, Albert, that you already had the answer? Yeah. So he's already seen this, right? And that's all he was doing, right? So he's multiplying the numerator by root 2 over 2. You follow me, Arjun? Arjun, you still there?
Yeah, I am.
Okay. So check this out. So now we have a way to do these, right? So here's my question. What if instead of, get rid of all this stuff. What if it was 10 over root 3? Then what would I do?
You'd multiply by root 3.
Oh, not root 3 over root 3, because I can't
Yeah,
just
root 3
multiply
over.
by, there you go, because root 3 over root 3 is really just what? What is
Uh,
root, what do you think root 3 over root 3 is?
1.
1. I'm just multiplying by 1 in a strange way, right? So what does this become?
10 root 3 over 3.
Over 3. So what if it was 7 root 3? 7 over root 3. What do you think it would become?
So you would multiply by root 3 over root 3, and you'd get 7 root 3 over 3.
There you go. That is how we simplify radicals. That make sense?
Yeah.
All right, so let's back up now. Let's go all the way back to this problem because we've talked for a while. Guys, that is how you simplify a radical, and that's what they're going to do on the test to you, okay? All right. So clean up this. Okay. So I'm going to start this completely over. All right, Arjun, you ready? Okay, what if I said this was 10 and I told you this was a 45, 45, 90 triangle? Remember what our relationship is, right? These will be equal. These will be equal. And this one will be whatever those are times what? What the heck just happened?
Whatever. Those two squared.
There's a shortcut. If these, we know these are the same, right? These are both x. What's
Yeah.
the relationship between that and that? Do you remember we were doing this? Remember what happened? When this was 2 and 2, This was 2 root 2.
Yeah.
When it was 3 and 3, what was it?
3 root 3.
No, not. Let's do this for
Oh,
you.
3 root 2. 3 root 2. Sorry.
3 root 2, because you get 3 squared plus 3 squared equals x squared, or I'll call it h for hypotenuse squared, right? So that's 9 plus 9, that's 18, equals h squared. Square root it, you get what? 2 times 3 times 3. So the 3's come out. So 3 root 2. You get it?
Yeah.
Okay. So 10 is going to be equal to what? Whatever x is, right?
Yeah.
Times root 2.
Mm-hmm.
Okay, so you see this algebra that I'm trying to solve here? So I have that math problem. 10 should be equal to whatever x is times root 2.
Yeah.
Follow me? Okay.
Yeah.
Now let's get x by itself. So we're going to divide both sides by root 2. Yeah?
Yeah.
Okay, now we're down to what we just did a few minutes ago, right?
10
So,
root 2 equals x.
so we get 10 over root 2. We're going to multiply by root 2 over root 2, right?
And
what
you
do we
get
end up with?
10 root 2 over 2.
Which is?
X. Right?
Which is what x is. But what is 10 over 2 really?
Oh, 5 root 2.
5 root 2. That's our answer. That's what x is.
Yeah.
All right. All right, next person. Ash, you there?
Yeah, I'm here.
Are you familiar with these, Ash? Are you pretty good at these already, or no? Be honest.
No.
Okay, good. That's the perfect person to talk to. Okay, what's the relationship again? If it's 45, 45, 90, which two sides are equal?
The legs.
The legs. So these are both x. And what will this always be?
It will be something root 2.
It'll be
Or it
whatever
will be,
x is times
yeah.
root 2, right? Okay, so now we're going to do this problem. So what if I said this was 12? Yeah? Now, listen, if these were 12, this is easy. If those are both 12, then this is just 12 root 2, right? That's easy. Agreed?
Yes.
Okay, but it's not. I'm telling you, these are. Hold on, my keeps crashing on me. Yep, I just got a full crash. Okay, the pin's not working. Oh, I'm gonna have to. Sorry, buddy, it just crashed on me.
It's fine.
Let me fix this. All right, back to you. All right, back to you. All right, so. Oh my gosh, now my pin's not working at all. What the heck? Okay, I gotta see if my pin's dead or if it's the program. I'm wondering if the battery just died. Wow. It's an update. Oh, that's gonna suck. That's why. Hey, Megan. Hey, do you have probably next year you're gonna have a Surface Pro? Yeah.
I was actually going to ask you that after class today.
And when the pin dies, it's usually when the pin stops working, it's usually there's an update to be done. So
Okay.
that is probably what's happening here. All right, and I can't fix that easily. I kind of want to just finish class. All right, so all right, I'm gonna try to type this without a pen because I can't do it without a pen right now. Well, can I fix it here? Let me see. Guys, I'm sorry. There's nothing I can do with this right now. It's Bluetooth. Buggiest program on the They seem to be done. Yay. Okay, well, that fixed it. Okay, we're back. Good Lord. All right, who was I talking to? Sorry.
You're talking to me.
All right, here we go, buddy. So if that's 12, right? This is much harder, right? Because I can't easily figure out because some number times √2 made this, right?
Right.
So whatever x was times √2 made 12, yeah?
Yes.
All right, so there's my algebra problem. How do I solve this problem?
So don't you put
What is √2 doing to x? What operation is √2 doing to x?
multiplying?
So we're going to divide both sides by √2. Okay. Do you see what
Okay.
that does for you? If you haven't done algebra before, you're probably still learning it. But these cancel. These make 1, right? √2 divided by √2 makes 1. So that's how I got rid of it. Right? All right. So I end up with this problem right here. 12 over √2. What's wrong with that answer?
You can't have √2 on the bottom.
Yeah, it's called a radical. I can't have a radical in my denominator. Okay, let's learn the words. Good. Yeah, so I can't have a radical in my denominator. So what do I multiply by?
√2.
No.
Or
So
√2 over √2.
there you go. Weird 1 is what I call that, right? That's 1.
Yeah.
Okay, so what does that do for me?
It gets you 1 over, or it gets you √2, or is.
Okay, so slow down. Stop. Let's do this first. What is 12 times √2? 12 √2.
12 √2.
Yeah, done. Just 12 √2. Okay. Now the harder part is what happens here. When you multiply √2 times √2, you get √4. Yeah?
Okay.
What is √4?
√4 is √2 times √2.
Well, yeah, but simplify it. What is √4?
It's 2.
It's 2. So that becomes 2. Yeah, the square root of 4 is 2. All right, so we end up with that, right? That's why we did that, because we got rid of the radical in the denominator. So we get 12 √2 over 2, which is really what?
12.
What grade are you in? What grade are you in?
I'm in 6th grade.
Okay, that's why. All right. You're going into 6th or you're going into 7th?
I'm going into 7th, but I did take 7th grade math this year.
Yeah, but you're still kind of like learning your algebra, so you're not like real strong at it. You're like learning it still. So
yeah.
What is 12 divided by 2 really?
6.
So this is just 6 √2. Yeah?
Yes.
Okay. So what am I saying? I'm saying that these have to be 6 √2. Does that make sense?
Yeah.
Well, let's see. Let's see if that's true. If those were 6 √2, would that give me 12? Let's see. So if those were 6 √2, would that give me 12? Because remember what we said, these are going to be equal, and this will be whatever x is times √2, right?
Yeah.
Okay, well, let's see. Is 6 √2 times √2 12? Let's see. What's √2 times √2?
√4.
What's √4?
2.
And that's 6 times 2, which is 12. It does work. You get it?
Yeah.
All right, cool.
Sort of.
It's going to be work. You know what? Let's do it. You know what? I like sort of. I like that you're at least honest, okay? So let's make up one. Ready? Okay, so let's say this is 20. Okay? And I tell you that these are equal, which means it's a 45, 45, 90. Now remember, anytime we see a 45, 45, 90, we're really just seeing half of a square. Does that make sense?
Yes.
Okay, so sketch out your square. Okay, so what do I know about these two sides?
They're even.
They're equal, yeah?
Yeah, equal.
So I'm going to call them equal. And what do I know that 20 is going to be equal to?
20 times, or 20 √2?
No. 20 will be equal to whatever x is times √2. You got to be careful with your vote. There you go. Okay, so that's an algebra problem. Do you see it?
Yeah.
All right. That's an algebra problem that you're solving. Listen, guys, people that are already good at this, you might be sitting there thinking you're all smug. I already know all this stuff. I'm so good, blah, 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 blah. Okay? You're good at it because someone taught it to you. What you could be learning right now, you could be learning how to teach it to someone else. Because just because you know how to do something does not make you a teacher. How to explain it to someone that they understand it is the key. Yeah? All right. So keep going here, buddy. So that's the algebra problem. Do you see how we got to that algebra problem?
Yes,
Okay. Yeah, we just let the math take us there, right? We don't have to memorize something. Let the math take us there. All right, so now we want to solve for x. So how do we get x by itself?
We multiply by root 2.
If we multiply by root 2, that actually does work, but it's not the best way to do it, okay? What is root 2 doing to x? It's multiplying. So what if we divided by root 2?
Okay, yeah, divide by root 2 then.
All right, so what does that do? These knock each other off. That makes 1, so we get x, right? So x is equal to 20 divided by root 2. All right, I'm going to be quiet now. What do I do to 20 over root 2?
Multiply by root 2 over root 2.
Bingo bongo. Root 2 over root 2. We get what?
We get 20 root 2 over root 4.
20 root 2 over root 4. And that's really 20 root 2 over
2.
And what is 20 divided by 2?
10.
So this is 10 root 2. You with me?
Yeah.